Well, we need to get that tangent x, that function, out of our exponent. So what we do first is we take the natural log of both sides. So the natural log of 2x to the fourth plus 1 to the tangent x. Now, we can use log properties from here. We'll bring the tangent x down. Natural log of 2x to the fourth plus 1. And we have natural log of y. All right, bringing that out, we can now use the quotient rule. We'll take the derivative of both sides. So on the left side, this is going to be, we'll use implicit differentiation. This will be 1 over y times dy dx. All right, now we have a product here, uv. So the derivative of the first is secant squared x times natural log 2x to the fourth plus 1 plus v prime, which would be 8x cubed over 2x to the fourth plus 1 times our tangent. Now, the last step we have, we want dy dx, so we are going to multiply both sides of this equation by y. Multiply both sides of this equation by y. Now, if you recall, y is actually 2x to the fourth plus 1 to the tangent x. So we get dy dx equals 2x to the fourth plus 1 to the tangent x times secant squared x natural log of 2x to the fourth plus 1. Nope, don't need that parenthesis there. Plus 8x cubed over 2x to the fourth plus 1 times tangent x. So that whole quantity multiplied by our original expression. Now, obviously, that is a very complicated derivative. So there are other methods we can use, however, this is the best. So if you recognize where log properties would be very helpful, moving exponents down, or splitting products into sums, quotients and differences, etc., recognize that and take the natural log and see what happens. All right, number 13, find the derivative of y equals x square root of 2x plus 1 divided by e to the x sine cubed x. All right, this is crazy by itself. Now, if we take the natural log here, it'd be nice to make the radical into an exponent, which we can bring down with log properties, etc. So this becomes natural log of x. I'm going to go ahead and write this as an exponent over e to the x sine x cubed. So this is going to be natural log of y, and I'm not, actually let's bring this down. I'm not taking my derivative yet. Keep that in mind. This is the natural log of x plus 1/2 natural log of 2x plus 1 minus natural log of e to the x. Now all of this is in the denominator, so we will subtract all of it. Natural log of, actually that would be 3 natural log of sine x. So let's go ahead and distribute that and make that a negative term there. Now, taking the derivative of each of these pieces here works out very nicely. This is 1 over x. 1/2 times 2 over 2x plus 1 minus 1, because the natural log of e to the x is just x, minus 3 cosine x over sine x. Now, multiplying through by our y, this becomes dy dx is 1 over x plus 1 over 2x plus 1 minus 1 minus 3 cotangent x, cleaning that up just a little bit, times x square root of 2x plus 1 over e to the x sine cubed x. And there we have our derivative. All right, last example for this section is a classic problem. This one comes up a whole lot as just the perfect example of logarithmic differentiation. First, we'll take the natural log of both sides. So we will have the natural log of y equals x natural log of x. Taking the derivative, we have 1 over y dy dx. And this is a product rule. So we have uv. The derivative of the first is 1, so 1 natural log x plus 1 over x times x. So natural log x plus 1 is 1 over y dy dx, multiplying through by y. This is dy dx is x to the x natural log x plus 1.